The following is a quadratic word problem regarding integers. And the thing that you have to know before solving this is this word consecutive odd integers. Well, you should first think about some examples of consecutive odd integers. These are like 1, 3, 5. These will be consecutive odd integers. Something like 11 and 13, that will be consecutive odd integers. If it was just consecutive integers, then it would be 11, 12, 13. These are the consecutive integers. But if you say consecutive odd integer, then you have to skip the even numbers and you get odd. Okay. Now, when it comes to consecutive odd integers, how would you define your variables? Well, the first number we're going to denote as x. So think of x like 11. Then what's the next odd number? Well, x plus 1 will be an even number. If x is an odd number, x plus 1 will be an even number, and x plus 2 will be, again, an odd number. So x and x plus 2 will be the two odd integers. Okay. Now, I have a product of 99. Okay, so it told us that this has product of 99, so it's x times x plus 2 equals to 99. And we have to solve this. Let's multiply it. X squared plus 2x equal to 99. X squared plus 2x minus 99 equal to 0. For quadratic equations, it's easier if you put everything to one side. Now here, you could use the quadratic formula, or you could even use completing the square, but I guess the easier way would be to try to factor this. You want to find two numbers that multiply to negative 99, add to 2, because it's negative 99, one number is positive, the other is negative. So the summation will be like a difference of two positive numbers. And it occurred to me that 11 times negative 9 is negative 99, and 11 plus negative 9 is indeed 2. See how the summation is like a difference, 11 minus 9, because 1 is a negative number? Yeah. So if you have a negative number here, often it's like finding something that multiplies to 99, and when you subtract it, it becomes 2. That's the number you're looking for. And that's how I figured this out. Okay, so those are the two numbers, and once you find those numbers, then this gets factored as x plus 11, that's one number, and then x minus 9 equal to 0. So this left side is same as this. Whenever you're in doubt, just try to FOIL it out and see if this matches with what you had before. You'll see that they actually match. Now you have two things multiplied to give you 0. That means either one has to be 0. Either it's that x plus 11 is 0, in which case x would be negative 11, or you have x minus 9 equal to 0, in which case x would be 9. Now it says find all sets of integers that satisfy this description. Now whenever you solve an equation and you get an answer, often you get too excited to look back and see what you've done. In pre-calculus, when you just write this as your answer, often it's not what the question was asking for. You have to actually think about what it is. Okay. So what was x? X, the definition was the first number of the odd consecutive integers. So the other number would be x plus 2, right? So this here actually corresponds to negative 11, and negative 11 plus 2 is negative 9. So that's the two numbers. And this one here corresponds to 9, and 9 plus 2 is 11. So those are the two numbers. So the two integers are negative 11 and negative 9, or 9 and 11. So those are the two possible answers. And it said find all sets of integers. So we found all the possibilities. So that's the answer. Here's another question. The product of two consecutive positive even integers is 14 more than their sum. Find the integers. Okay. Now, this time it's a consecutive even integers. And think about an example of a consecutive even integer, like 2 and 4, that's even. Like 10 and 12, that's consecutive even. Once again, if you call the first number as x, the second number will be x plus 2. Note that this even, if even was missing and it was just two consecutive positive integers, then consecutive numbers are like 2 and 3 or 10 and 11. These numbers are like x and x plus 1, right? So in those cases, you should use x and x plus 1. But here it's even, so we don't do this. Okay. Now it says the product of two consecutive positive even integers. So this much. And by the way, this is a great example of analytical thinking. See, when you have a big word problem, it's good to divide the entire thing into small parts where you can digest. Okay, so I don't really see where this question is going, but you can just read the parts about two consecutive positive even integers and say x and x plus 2. And then it says product, so you multiply the two. And that takes care of this much. So that's good, because once you have taken care of this much, then you don't have to worry about this part anymore. Now it says 14 more than their sum. Okay. Well, I think what you want to do is to figure out their sum first, and then worry about what 14 more is. Okay. So the stages of thinking is like this. First, you think about the product, number 1, and then you think about their sum, number 2, and then think about what 14 more is. Okay. So let's look at their sum. Sum means addition, right? So you add the two numbers. Product means multiplication. Sum means addition. Okay. Maybe if you didn't know that, you should learn that now. Product means multiplication. Sum means addition. Okay, so we have two numbers. Now let's think about the 14 more. So you have product and sum, and it says product is 14 more than the sum. Okay, so you don't have to pay attention to these other details. If you want to understand what 14 more means, just try to think about the keywords here. So product is 14 more than the sum. Okay. Now, try to digest this. Does this mean that the product is bigger or the sum is bigger? So if you say A is 14 more than B, if you say Tom has $14 more than Jack, who has more money? Tom has more money, right? So this is bigger than this. So that's the first thing that you should think about. And the next thing is, now you want to make an equation, right? See, you need to write an equation so that you can solve the equation. So you want to write equal sign, but clearly the left side is bigger than the right side. So if you want to make them equal, so for example, Tom has $14 more than Jack, and you want to make them equal, do you give $14 to Tom or to Jack? Well, of course, to make them have the same amount of money, you give $14 to Jack, so that now they have the same equal amount of money, right? So think about this. So you can easily conclude that if you add the 14 here, then the two sides will be equal. All right? So it may seem like I'm somewhat approaching this in a roundabout way, but see, you can always make an abstract problem concrete by thinking about examples and just thinking about small questions which can like check your thinking. Right? Rather than just seeing the 14 more and trying to add it to some place, and often students get it wrong and they add the 14 here. First ask which side is bigger, and then ask, okay, now I want equality. So to which place should I be adding the 14? And if you ask these two questions, it's clear that 14 has to be added here. Okay. All right. So you have x times x, that's x squared. X times 2 will be plus 2x. Over here, x plus x will be 2x. 2 plus 14 will be 16. Now I guess you can subtract 2x both sides, and you get x squared equal to 16. And I know that when you have x squared equal to a number, then you can take the square root to solve it. So square root of 16, which is 4. But don't forget, whenever you do this, you need to put two numbers, plus or minus. So we get this answer, x equals to 4 or x equal to negative 4 as the two answers. Now, let's think about the following then. We have positive. This is one word that we didn't think about so far. It's positive. So can x be negative? No, it has to be positive. So that's wrong. And then when x is 4, x plus 2 will be 6, because 4 plus 2 is 6. So the two consecutive even integers are 4 and 6. So that's the answer.